Okay, so this stuff is for section 4.3. You'll notice in your book, I think that's about page 255, where we get started. And all we're asked to do is to factor. Most of these will be trinomials. And trinomial obviously focuses on there being three pieces. We can look here, there's 1, 2, 3 pieces in this problem. This is not necessarily from your book. I just made these up as I went, except for the last problem. But here we see that we have the 3 pieces. The first term is x squared. And in today's assignment, all of the problems that you'll do will not have a number here in front of the x squared. That's good. It makes the factoring easier. And so when we go to do the factoring, we're hoping that it'll fit inside of 2 sets of parentheses. The first term, okay, in each of those parentheses comes from our x squared. So we'll have an x here and an x here. The next step is the signs. When it comes to the signs, we always look to second sign first. We look there first. So we're looking right here. It's a positive. Now positive signs mean that the signs will be the same, meaning that the sign that goes in each parenthesis will be identical. Negative would mean that the signs are different. Okay. Well, we know this is we know that they're the same. Now we're going to come over here, and the first sign will tell us what? What to use. It tells us that the signs need to be positive. So I'm going to put the plus and the plus here. And then the last step is to come here for 6. It's going to give me the pieces at the end. And I'll take the 6. I'm going to split it into all of its factors. 1 times 6 is 6. 2 times 3 is 6. Now when I combine these by addition, I want it to add up to the middle term. Well, 1 plus 6 is 7. 2 plus 3 is 5. So 2 and 3 must be my answers. So 2 and 3. And I'm done. Again, you can pause this video if you feel like you need to go over that again. But we're going to move on. The next problem, this is what we call a perfect square trinomial. And there's a pattern for it on page 253 in the key concept box. But what we're going to look for is we're going to see, okay, there's my 3 pieces. That makes it a trinomial. We notice that the x squared is just a squared value, and that the 81 is a perfect square as well. When we see that, we're going to see if we can see a special pattern that's really good for us to make a shortcut. Here we know x and x. I look to my second sign. It says they're the same. And then I come to my first sign to see that they will be negative. So negative, negative. Now I could go through. 81 actually has quite a few factors. 1 will go in, 3 will go in, and 9 definitely goes in. There may be more. And I could try to go through all those factors, but because 81 is a perfect square, I'm going to try just the square root. The square root of 81 equals 9. So I'll try to use 9 and 9. Now I want to make sure that this works. And so 9 times 9, the negative and negative cancel. I get positive 81. Then I have negative 9x, negative 9x. You know, negative 9x plus negative 9x equals negative 18x. That's my middle term, so this is it. These perfect square trinomials will be simple to factor if we realize that the square root of this, if it's half of my middle term, I'm ready to go and I can just use that duplication. Another way to write my answer would be x minus 9 quantity squared. Okay? So you could square the quantity. That's another way to write your answer. Either one is acceptable. They're both equivalent. So that's a perfect square trinomial. There's a section in the text that says factoring with special patterns, and this and the next one fit into those categories. This is what we call a difference of squares. And the reason we call it a difference is because there's a subtraction sign. And then squares because both the 36 and the x squared are perfect squares. So when we set up the parentheses, we know we'll have x and x. The last sign, this is negative. And if you remember from earlier, if it's negative, the signs differ. And so I'll have a plus and I'll have a minus. And then all I'm looking for, because this is a difference of squares, there's no middle term. There's no 6x, nothing in the middle to help me with the process. So I'm going to take the square root of 36, which is 6, and I'll put 6 here, 6 here. If I were to FOIL this, I'd get a positive 6x, I get a negative 6x, and those would give me 0x, which is not part of the problem. That's why I don't have a middle term here. That's a difference of squares. Very, very useful to us. The last problem we're going to look at has this equal sign involved, and that can throw us off a little bit, but we're going to start with just the standard factoring. We'll have our x and our x. I look at my signs. They are different. So I'll put a plus and a minus. You could do minus plus, it doesn't matter. Where we put the number will make a difference. Okay, and then I'm going to take the number negative 5 and I'm going to factor it into its factors. I have 1 and 5 and nothing else really goes into 5. So I just need to decide which one's positive, which one's negative. Well, 5 is the bigger number, and the bigger number always gets the same sign as the middle term. If this was a plus, 5 would be a plus. Because it's a negative, 5 gets a negative. Now when I add 1 minus 5, or 1 plus a negative 5, I get negative 4. That is the number I'm looking for, so I know that I'll have plus 1 minus 5. The factoring is now done. However, I want to know what makes this equation true. And if this parenthesis equals 0, or this parenthesis equals 0, the multiplication, the FOILing, would give me 0 as a result. So I want to ask what makes this parenthesis 0. X plus 1 equals 0 when x equals negative 1. This one, we could do the same process again, but I also noticed that the difference between this parentheses and this equation is that the sign has been changed on the 1. So here, I'm just going to say that x equals 5. Because if I change the sign, if I added the 5 to the other side, I would end up with x equals 5. Finally, this last problem is one from your book. It's problem number 36. There are two issues. First, it doesn't say equals 0. We need to fix that right away. So we'll subtract 7m from both sides. So we end up with m squared minus 7m. They are not like terms. They don't have the same exponent. That equals 0. Now that we're here, well, we realize we're missing the last term this time. So we can't do, it's not a difference of squares. 7's not a perfect square, plus there's the m. There's a lot of issues with that. So my normal factoring methods won't work. I needed 3 pieces. So what I'm going to do is I'm just going to say, what do they have in common? What's the LCM? Okay. And I look and I see, well, let me change that. It's the GCF is what we want. Greatest common factor. And I notice that they both have an m. So I'm going to factor out the m. And I'd be left with m minus 7. And remember, we're undistributing, so m times m is m squared. M times negative 7 is negative 7m. So this is a valid statement. Then I'm going to ask the question, what makes each of these equal to 0? Over here, well, m equals 0. Over here, m equals positive 7, because I know I would just switch the sign. And those are the problems that I wanted to go over today. Hopefully you're getting the hang of it, you're remembering some things. Check the back of the book often for answers and bring questions to me on Wednesday and Thursday. And good luck.